Good morning, everyone, and welcome to today's webinar from Carmenta. I'm really glad to see that so many have joined us today. It's 10 o'clock and it's time for us to start. So let us begin by introducing ourselves. My name is Pelle Arvinder, and I am the product manager responsible for Carmenta's web map service. That is Carmenta Server and Carmenta Server Core. And I will be hosting this webinar from the Carmenta Stockholm office, where we have really nice but a little chilly weather outside today. With me today is also my colleague from the Carmenta Gothenburg office, Thomas Jonsson Damgård. Would you like to say a few words, Thomas?
Yes, sure. So hi, everyone. I hope you're all having a great day today. And I agree, it's a bit sunny here in Gothenburg as well. I'm Thomas. I'm a software engineer here at Carmenta Geospatial Technologies. I mainly work with the Carmenta Engine SDK. I do part-time consultancy work and also mostly internal work here at Carmenta. And today I've prepared some demos together with Pelle for you guys to enjoy. So yeah, stay tuned for that. But other than that, I hope you're all having a fantastic morning, and over to you again, Pelle.
Thank you, Thomas. So we will share the next 45 minutes or so together with you, showing you how to publish interactive web map services to allow a client to interact with different geospatial analysis hosted on the server. And this will be done with the minimum of coding in both the web application and on the server side. We will get into a little bit of technical details along the way, but I think that the general concepts that we will demonstrate will be interesting, not only for developers, but also for instance, architects and system integrators. During the webinar, we will switch between presentations and some pre-recorded demos to illustrate the different steps leading up to a fully working client-server demo. If you have any questions along the way, there is a Q&A button in the Zoom client that we use where you can post your questions. At the end, we will have a little Q&A session where we will try to answer your questions. Should you instead prefer to contact me directly afterwards, you find my contact details here and also at the end of the webinar. So let's begin by having a look at what we'll cover. First of all, we will have a look at the map configuration. This is the definition file that describes the data sources that are used, how they are processed and rendered and structured into different map layers. The Carmenta Server SDK tools, Carmenta Studio and Carmenta Explorer that are used to edit and test run the map configuration will be investigated. And the built-in analysis component for line of sight analysis will be described. Next, we will look at publishing a web map service from the map configuration. We will take a look at the web map server, Carmenta Server Core in this case, and see how a Docker container is started from the Carmenta Server Core base image. We will then prepare the map configuration containing the line of sight analysis and publish it as a web map service. And this will be a passive service to start with. After that, we will switch to the map client and look at a small and simple web application using the open source library OpenLayers. And we will add the map layers from the published map service to the map client in the browser. And then, as a final step, we will modify the map client and add an observer feature to the web application, and then use the built-in tools in OpenLayers so that we can move it around in the map. And we will then change the client so that the calls to the map service will include information about the current observer position. And finally, on the map server, we will add a custom component with a little bit of code to modify the observer position on the server side that is used to render the line of sight viewshed. All of this will get a lot clearer as we go through the different steps one by one. But before that, let's have a look at the complete client-server demo of our line of sight analysis in the web application. So if you're familiar with the Carmenta engine and its samples, you probably recognize this simple but quite effective line of sight analysis sample. It uses a built-in line of sight component called the line of sight operator. And it takes an observer position and uses elevation data to analyze the line of sight from that observer position. So what is a bit different here then is, of course, that we are running this in a web browser. So we use the same elevation data that is used for the actual line of sight analysis to visualize it using a hill shading component. And we also have a bit of terrain colorization in this map. So what I have in the client is basically a very small open layers client with one little vector feature that I can hover over, and I can move it around. And once I move it, its position is sent over to the server, and the line of sight is rendered server side and returned as a raster image, a traditional WMS getMap raster image. I also, of course, can change the height or the altitude of the observer, and I can change the actual view shed range, the range that the observer can see from his position. And this observer could then, of course, be a static analysis where you analyze something that is seen or can be seen from a certain position, but it can also be used as, for instance, to track a moving UAV or something similar, to see what the UAV is able to see from where it is and what is hidden from it, depending on the elevation in the terrain. So with this complete scenario in our mind, let's begin with looking at the map configuration and the line of sight analysis component. So if we go back to the entire scenario that we will build, we will now be looking at the first parts here.
Hello everyone, and welcome to the first demo. And in this demo, we'll talk a little bit about the Commenta configuration file, known as the PX file, that is used to create the map that you saw there inside of that web application that had this little interactive line of sight operator that you could move around the mountains and see how far you could see from certain vantage points. So included in the Commenta server core, there are two additional Commenta products. One of them is Commenta Studio, and the other one is Commenta Explorer. So right now I have Commenta Studio opened up with our little PX file inside of it. So this is the final project file that is used to generate the map. But yeah, you can sort of straight up see that there's some sort of visual programming here where you have all these different components and they are all hooked together to create this final view here. So sort of suitable name here for the final view. But yeah, so these are Commenta configuration files, and it would be lovely if you could preview them just to see that you did all the mapping correct. And to do that, we use another Commenta product known as Commenta Explorer. So using Commenta Explorer, we can now preview our Commenta configuration files and see whether we have done the mapping correct or not. So I guess the most important part here to take away is that the data flows from right to left. So the farthest right component here are all sort of raw data points. Here we see a TIFF file, here we see an elevation bill file, and here we see some sort of observer memory data set. It's basically just a feature point for the observer. And they sort of get fetched to their own visualization operators. And then further down the road, they finally all converge to this singularity point over here known as the view. So every component that is hooked to this component here will be drawn on screen. So let's start with the background map. So it's going to be inside of this layer known as the land use new colors layer. And so here we can see that our TIFF file is hooked inside of a read operator that is later fetched to our visualization operator that has a raster visualizer to draw this raster data. And it has this bi-cube filtering and some sort of coloring scheme. And also we also need the elevation data. So here we have read operator 4 that has some bill file hooked onto it. We also see some indexing and whatnot. This is mainly to do some performance enhancing, but it's not really important right now. The main important part is that we have the elevation data hooked to this one. And then it also goes through the shade operator, which is mainly used to create this shading effect to really illustrate the difference in height. And then finally, it also is hooked to a visualization operator with another raster visualizer. And these are all grouped together here with this sort of layer set or group layer
component. And since all of these are going to be static, that is, these parts are not really going to change, it's just our background map, this entire layer here is going to be cached. We're going to see that later on. So this is just a static background map part. And now let's go down to the more interesting part. So in this layer group, known as the viewshed layer, we're going to see all of the line of sight operator. So in the furthest right part, we can see that we have the elevation data. Not too much of a surprise, that is the exact same layer elevation data as before, just to get the exact same reference points when we calculate line of sight. And then we also need this observer memory data set. It's basically just to create the little feature point you saw there that we can move around. So it has the name observer feature, and it has this range value that I believe is set to 3,000 units. Yeah, so we have a range of 3,000 units. And so the read operator for the elevation data is hooked on the line of sight operator. And then the feature point is hooked onto a visualization operator for a symbol visualizer, and it's going to be a circle. So it's just to visualize the observer as a circle. And additionally, we're going to have a line visualizer that's going to create some sort of outer ring based on the range. So the range value here all refers to the same range value inside here. That is the unit range of 3,000, and it's all contained inside of this group layer. That is going to be dynamic because you're going to be able to move this around and there, and every time we move it around, we're going to have to recalculate the line of sight. So yeah, that's basically our configuration file. I hope that you could follow through a little bit. And here we have, in our final view, we have some drawables and some nominal scale here. And finally, we can preview it once more here inside of Command Explorer. So once again, we have just some raster data combined with some elevation data, some shading effect, and then a feature point generated inside of a memory data set, where we have created a symbol visualizer for the center point, and then some circle visualization for the outer ring that is based on the range, and then the line of sight operator to create this little reddish area to indicate that we can see it from this vantage point. But yeah, that's it for this first demo. And in the later demos, we're going to talk a little bit about how we can publish this Commenta map up to our own Commenta server.
Thank you, Thomas. So the map configuration that we just looked at is the basis for publishing web map services in Commenta Server, Commenta's web map server. And Commenta Server actually comes in two different versions. Commenta Server for Windows Server and Commenta Server Core for Docker containers. In this webinar, we will be using Commenta Server Core for our demonstrations. But the same techniques and principles apply to both Commenta Server versions when it comes to publishing map services and interacting with them. It's just the hosting environment that differs between the two. So for those not familiar with containerization and Docker containers, there are, of course, plenty of good resources available online. And when we first released Commenta Server Core in 2019, we held a webinar covering these topics in a little bit more detail as well. But before we jump in to the next demo, I just want to give you a very short and general summary here. So containerization is a virtualization technique for OS virtualization, where you have a container engine running on a host, and this host could be Windows, Linux, or it could be a cloud platform as well. And the whole point is to try to improve the resource utilization by allowing high isolation and portability of software components, the containers. And Docker is one such popular container engine, and the one that we will be using today. So in Docker, an image is used as a blueprint or template for starting containers from. And in short, the image defines a number of read-only layers with the writable layer being created when a container is started. And a Docker container may be completely self-contained with no external dependencies at all. But normally it makes sense to share, for instance, large data sets on disks using mounted volumes that then can be shared across different containers. And especially for geospatial data that quickly becomes quite huge. This makes a lot of sense. So Commenta Server Core is a high-performant mission-critical web app server, and it allows publishing of different map services on various standardized interfaces, including a large number of OGC services, for instance. And OGC is, as you probably know, the Open Geospatial Consortium. And it also supports, for instance, vector tiles and services for web-based 3D maps using Cesium. Commenta Server Core is delivered as a number of Docker images based on different Linux distributions. And the Commenta Server Core images may either be used as they are to run Docker containers from, or they can be used as base images for further customization. And the map services that are published in Commenta Server Core are defined in map configuration files. And these are exactly the same files that we looked at in the previous demo. And the map configuration supports some additional properties that you use to specify if and how Commenta Server Core should publish the map services, and also what metadata to publish along with it. Internally, Commenta Server uses the Commenta Engine runtime to read the map configuration files and geospatial data sources, and to render the responses to the HTTP requests that the web map server receives from the client. And these requests that are sent from the client generate responses that may either be, for instance, raster images, it could be documents containing vector features and others. And finally, Commenta Server Core's container supports scaling both up internally inside a container, but also out of the multiple containers in the service. And this service could be provided by, for instance, Docker Swarm or an orchestration framework such as Kubernetes. So let's have a look now at how we start a Commenta Server Core in a Docker container and how we publish the map configuration that we are going to use as a map service. So this corresponds to these parts of our scenario.
In the following demo, we will look at publishing the map configuration from the previous demo as a map service in Commenta Server Core. This will allow us to consume the map layers in a web application later. Commenta Server Core is a map server for Docker containers and is delivered as a set of Docker images. This first Docker-related part of the demo only applies to Commenta Server Core and not Commenta Server for Windows Server. Once we have started the Commenta Server Core container, everything that is shown later applies to both versions of Commenta Server, since all services and interfaces that are published are identical in both Commenta Server versions. For this demo, I'm running Windows 10 with Docker Desktop and will be using its command line interface, the CLI. There is also a dashboard available with Docker Desktop. Let's start by having a look at the Docker images that are currently loaded. As we can see, there are two Commenta Server Core images loaded in Docker. One labeled 2020.0 Ubuntu, which is the Ubuntu-based image of the last Commenta Server Core version that was released just before Christmas. The second image labeled dev Ubuntu is a nightly build of the current development version. Once we start our container, it will look just like any other host or server to us. It will have its own IP address, and to access it, we will need to attach a remote shell or similar. To make it easier to access Commenta Server Core running in the container, it's usually convenient to use one or more mounted volumes. This allows us to map Windows folders to the Linux file tree inside the container. This makes it possible to access some of Commenta Server Core's folders directly in Windows, for instance the catalog folder with map configuration files that are published, folders with geospatial data, and folders with log files and others. To start the Commenta Server Core container in Docker, we will use the simplest alternative, the docker run command, with a number of parameters. The parameters for our run command include specifying two mounted volumes. It also contains a mapped port, which is a convenient way to access ports on the container directly on our local host. In our case, we will map the web service port 80 in the container to port 8000 on our local host, which means that we don't need to know the actual IP address of the container to access its web server. We simply browse to port 8000 on our local host to access Commenta Server Core's map services and built-in tools. We will also supply a settings file containing environment variables to our run command. These are used by Camenta Server Core at startup time for initial configuration. With this in place, let's start our Camenta Server Core container. We can check that the container has started and is up and running. Camenta Server Core has a couple of built-in tools accessible from the web server in the container. One of them is the service list, where all published map services are listed. The service list shows us all map services that have been loaded and published from different map configuration files, together with all interfaces that they support. In our case, we have 2 map configuration files in the catalog folder, which are published as map services, each with several different interfaces. When we select one map service, we can see a preview image of it and links to the different capabilities documents and endpoints for all services. There is also a built-in map previewer to preview a selected map service. As a final step of this demo, we are going to publish the map configuration for our line of sight demo. In order to do that, we need to make a small change to it and save it to the catalog folder on the mounted volume. This catalog folder is monitored by Camenta Server Core to detect new and changed map configuration files. The minimum information needed is to specify that the view in the map configuration is a catalog map. This will allow Camenta Server Core to detect and load the map configuration and publish it together with its metadata. So I'm saving it to the monitored catalog folder here. And if we now look at our service list again, we can see that it's updated with the new map service. And finally, we can preview the new map service in the map previewer. We can see that the map previewer shows us that the map service has 2 map layers, one for the background map and one for the line of sight map layer, containing the observer point and the line of sight viewshed. The line of sight map layer is completely static right now, as it's based on the static observer feature in the map configuration that is published. This is something that we will change in the coming demos.
So now that we have our map service up and running in a Docker container, it's time to have a look at the map client. In the previous demo, we used the bundled Camenta Web Explorer, which is a map previewer that is running in the Camenta Server Core container. And although it is in fact built on open layers internally, we are going to build a small and simple open layers-based map client ourselves, since we want to add the necessary functionality to allow interaction with an object in the map. And that is, in our case, the line of sight observer's position, of course. OpenLayers is an open source JavaScript library for 2D maps in web applications, which can be easily integrated to enhance the web application with advanced mapping capabilities. OpenLayers supports a large number of standard protocols, including different OGC services, Mapbox vector tiles, OpenStreetMap slipper tiles, and others. Besides consuming map services and visualizing the map layers in them, OpenLayers also contains built-in tools for instance, manipulation of map objects, and also a rich API for geospatial operations. And there are, of course, other libraries and clients that can be used to consume the map services published in the Camenta Server Core, as long as the clients are compatible with the protocols that are used as well. And these include, for instance, Leaflet for 2D and Cesium for 3D web applications. So let's have a look at how we can consume our map services in a small and simple OpenLayers web application.
Hi everyone, and welcome to demo number 3. So in this demo, we're going to talk a little bit about how the web application is built. In the previous demo, Pelle showed you guys how you can publish a map service to our Camenta server running inside of a Docker container. And in this episode, we're going to talk a little bit about how we could connect that published web server to work inside of our web application. So right now I have a project folder open up with some of the essential files needed to create this web application. First off, we have our standard HTML file for the web application. Then we have a map CSS style sheet to style some of the components. And then the most crucial part here is that our map.js file, which is going to be the JavaScript needed to connect our published map services. And also we have this folder here with a weird name that usually indicates when it has some sort of version to it that is a library, and that is indeed true. Today we're going to be using the Open Layers library to connect our WMS services to our web application. So we have our OL CSS file and our OL JS file, and also these map controls. But yeah, so I've opened up our project inside of Visual Studio, and now I'm going to go through some of the files here. We're going to start out with the basic one, or HTML file. So inside of these header tags, we have now included some of our resources. We start off by including our style sheet. This is our own map.css style sheet, where we're going to be taking a look at in short. Then we have included the Open Layer style sheet, and also we are also running the OL JavaScript to get all of those components. Now let's take a little bit a look at the body section. Everything inside here is always going to be visible inside of our web application. To start off, we have a div with an ID map and a class name map. And of course, here we're going to have our map control, or our map in general. Then we have some additional input fields here. We have a height that's going to be the height of the observer, and also the maximum range, which is going to be the maximum range of the line of sight. And finally, and most importantly, at the end of our body section, we're going to run our own map.js JavaScript. So now let's take a little bit of a look at the CSS file. There's nothing too interesting inside here. We're just styling some of our components here, our input fields and our map and our labels. So there's some text manipulation here to make the text look better, some positioning and some margins and padding. So nothing unusual inside here. Okay, let's now take a look at the JavaScript file. So the JavaScript file starts with two global variables. The first one is going to be the background map layer. That was the top part of the configuration file. So in here, we're going to have the TIFF layer, and we're also going to have the elevation data. And then we follow up with the line of sight layer. That's going to be the viewshed layer. That was the bottom part of the configuration file. So inside of here, we're going to have our observer point, and also we're going to have our line of sight operator. And then we call the create layers method to generate these. So to do this, we're going to use the Open Layers library, and then we're going to create a layer. And to do this, we're going to start off by fetching it on URL. So if you remember in the previous demo, Pelle published his map as a map service inside of a Docker container at port 8000. So to do this, we do localhost port 8000 map services, and then we fetch the project file named. So in this case, it was line of sight webinar. And then in order to get the specific group layer known as background layers, we have to do is add the additional parameter layers and then give it the name background layers. So now we have fetched our service right here, but now we need to specify what type of service we want. And since the background map is going to be static, it's not going to change, we can abuse the cached feature that the tile services provide. So here we want it as a tile, so we're going to get this as a WMTS service because it's going to be cached. So for the line of sight layer, we're going to do something very similar. We're going to give it the URL, the additional parameter layers, and then the viewshed layers. So it's a different name. But since we're going to be able to, or we wish to move the observer around and thereby recalculate the line of sight, we do not want the cached feature here. So we're just going to have an imaged, so just a standard WS service. So now we have our layers, and it's time to create the map. So in order to do this, we're going to use a variable map that is linked to our div with the ID and class name map inside of our HTML file. And so to do this, we're going to create ol.map, insert our background map layer, our line of sight layer, target it as a map control, and then to create the initial view. Here we have just hard-coded the observer points as a starting point, and then we have some arbitrary zoom level. So now I have published this web application locally. So we're going to take a look at it. So I named it line of sight webinar. And so this is what it's going to look like.
So we have successfully managed to get the background map here. We see the TIFF layer, our elevation data, our shadowing effect, and here we also have our observer with the reddish area indicating the line of sight. Unfortunately, however, I am unable to move these observer around, and so we still just have the static appearance of this map. So in the last demo, we're now going to talk a little bit about how we can make this or turn this into an interactive map, since we wish we would be able to move this observer around and recalculate the line of sight.
Okay, so what remains now to add to our demo are two things. First, we are going to add a vector feature in the web application for our observer, together with a little code to allow us to move it around in the map. And second, we are going to send the observer's updated position to the map service and use it when we render the line of sight viewshed, so that it becomes non-static and follows the actual observer position. Sending the observer's position to the server will be done by adding a couple of additional parameters to the HTTP request that the client will send each time the observer is moved and the line of sight map layer is updated. On the server, we will update the observer feature in the map configuration with the HTTP request parameters. And to do this, we are going to use a custom component in the map configuration. Custom components allow us to extend the built-in functionality of Commenta Server by adding a proxy component to the map configuration that will call our own code. And this code can be written in .NET Standard, C#, for instance, Java, or C++. And there are different types of custom components that can be added at different places in the map configuration. So there are custom datasets for accessing data sources not supported out of the box, or for generation of completely new features. There are custom operators to manipulate the features in an operator chain, to modify features, filter, or aggregate them, for instance. And there are also custom visualizers and custom symbols for advanced custom visualization beyond what is already provided by the Commenta Server SDK. Custom components may be debugged by attaching a debugger to the Commenta Server core, for instance, by attaching Visual Studio to the .NET process that is hosting Commenta Server core map server for a .NET Standard custom component. In our map configuration, we will be adding a custom operator that will extract the observer's position and range attribute that are sent from the server in the HTTP request. And we will use these to modify the observer feature in our map configuration with the values from these. In the custom operator, we need to implement functionality to retrieve the parameters that are sent in the HTTP request and to find the observer's feature so that we can modify it before the line of sight viewshed is rendered by the line of sight operator in the map configuration. So we will have a look at this in the next demo and also look at how we can set this parameter in the HTTP request that is sent from the map client.
In this last demo, we will add a movable observer point to our web application and connect it to the map service on the server so that we can get an updated line of sight viewshed when we move the observer in the map. To start with, we will add a little JavaScript code for an observer feature in the map client. First, we add some variables to store the observer's position, range, and height. Next, we create a vector layer for the observer feature together with the feature itself. Then we add the vector layer to the OpenLayers map instance. And finally, we add an OpenLayers modify interaction to allow interaction with the observer feature. All of this is standard functionality in the OpenLayers library. Next, we add a little code to handle the two text fields to change the observer's height and range. With this, we have a map application with a feature that can be moved around. And we can see that the vector feature in the OpenLayers application can be moved around, but the actual viewshed map layer from the server is not updated at the moment. So what remains now in the web application is to transfer the updated observer position to the map service. The viewshed map layer is loaded as a WMS raster image using a WMS get map request. The WMS protocol of course does not support sending an observer position, etc., but we are allowed to add regular HTTP request parameters when we call the map service. Camenta Server Core is already prepared for this, so that any HTTP request parameter that begins with context underscore and a name will be accessible on the server side. So let's start by adding a little JavaScript function for this in the client. Let's call the function update line of sight viewshed. This function will add 4 parameters to the HTTP request that is sent to update the viewshed map layer. Each parameter begins with context underscore as its name. And then we make sure that we call this function when the observer position or the text fields change. This will now ensure that the WMS getMap request will always include 4 additional HTTP request parameters to the map service. On the server side, we want to modify the map configuration so that we intercept the right now static observer feature and change its position and attributes so that the line of sight operator can use the current values when calculating and visualizing the viewshed. To do this, we are going to use a custom operator. The code for this operator is written in C# and .NET Standard and looks like this. Without going into too much detail of this code, I would like to point out a few things. First of all, it inherits from the custom operator adapter in the Camenta Engine SDK. It uses the iterative processing mode, which means that it will handle each feature that passes through it one by one. When Camenta Server Core initiates a map update sequence, which for WMS means rendering a new raster image in response to the WMS getMap request, the onPrepare method is called. In this method, we can access, among other things, the additional HTTP request parameters that will be sent. And note that their names now lack the context underscore prefix that we send from the client. Finally, the onProcess method is called once for each feature, which gives us the opportunity to change the feature's position and attributes. It's also possible to filter features or generate new ones in a custom operator. The assembly that we build from this code will be used in our map configuration. We copy it to our catalog folder so that Camenta Server Core will be able to find it and load it. Next, we open our map configuration in Camenta Studio again. In the map configuration, we add a custom operator proxy component. And we configure it to use the assembly and the class that implements our custom operator. When we save the updated map configuration, Camenta Server Core will load it and republish it again automatically. Switching to the map client again in the browser and reloading it, we can see that the viewshed map layer is now updated every time we change the observer's position. We can also change the observer's height and the range of the viewshed from the observer's position. So with this we have concluded our demo steps, building our simple web application with a server-side analysis function with client interaction.
So, with the last demo step completed, I hope that you were able to follow the different steps that we took to get our little interactive client-server app together. I also hope that you hopefully got some ideas for how this could be useful to you and your applications. And it should also, of course, be noted that even though we wrote our client as a web app in JavaScript, the client could, of course, be any OGC compatible client that can send an WMS get map request and attach these 4 HTTP request parameters that we sent for the observer position and attributes. So it's not only applicable to a web application. Before we round off, looking at the questions that you have sent in during the webinar, and keep writing them if you have more. I would also just like to show you a couple of more examples of analysis services as demos to demonstrate more of the analysis functions in Commenta Server. First, we are going to look at a little demo that visualizes bathymetric data in different ways, and then use it for a simple under keel clearance analysis. And second, a little demo that uses elevation and terrain classification data to do a terrain routing and accessibility analysis. So this is again the Lake Tahoe area that we tend to use for many of our demos. So here we have the land elevation visualized with the hill shading. And if I turn on the bathymetric data, I can use the same shading based on the bathymetric data. The bathymetric data can then be used for other analysis as well. And at the moment, we are using static analysis that are running on the server side. So I'm enabling web map layers for each of them. So the same bathymetric data can be used to colorize depending on the depth of the lake. And Lake Tahoe is a fairly deep lake. Actually, we can also use the same bathymetric data to draw isoline contours to show us the depth, and we see that the lake goes down to over 500 meters depth. So with this, we are using one set of bathymetric data to visualize it in different ways. There are more things that the bathymetric data can be used for. There is a built-in ridge analysis operator that can be used both for elevation data, but also for the bathymetric data. So here, this analysis is analyzing the data and finding ridges marked in blue, valleys marked in purple, peaks and basins marked with blue and red. And all of this is done on the fly using the bathymetric data and rendered as raster images that are sent to our client. Finally, in this demo, I have a little ship route. So far, everything that is visualized here is sent from the server, but similar to the demo that we built, I also have a vector feature, which in this case is a line feature in this demo. So it's a vector feature with a number of nodes, and this represents a ship route. On the server side, we can visualize a route buffer, because we are going to analyze this ship route to find potential obstacles below the lake surface. We can analyze the depth at each of these waypoints, and if I move my the vector in the client, it's sent over to the server exactly like we did with the line of sight analysis, and we get back the current depth at each of these waypoints. We can also do this simple under keel clearance, which analyzes, and I'm going to turn off the colored layer so that we can see a bit clearly here. So we can see marked in purple here areas that are potentially hazardous for our ship route. And we are analyzing now 200 meters on each side and 75 meters below our keel. And of course, moving around the vector feature in the client, we will re-render the layer for this. And we can also, for this route, analyze and find the peaks that are highest in this area that we analyze, and also indicate for our different route legs if they are currently risking of in the risk of actually hitting something below the surface. So you can see the difference between a clear marked leg and one that has obstacles that are potentially problematic for our ship. The second demo, we move from the lake to the land area. And in this demo, we are using elevation data and terrain classification data. We are visualizing it again, server side. We are going to analyze a terrain vehicle that has certain characteristics, including the slope grade that it's available to run. So areas marked in brown here indicate areas that are inaccessible for our vehicle, for instance, due to deep slopes, or it could be terrain that our vehicle is not able to pass. Again, similar to the previous demos, everything is rendered server side except for a line feature with start and an endpoint. So for this, we can analyze and render the terrain route between the start and the endpoint on the server side. So we are now analyzing and trying to find the best route. And if we change the positions, it's recalculated and we get an estimated driving time depending on the terrain conditions and our vehicle. And of course, we are going to try to use the roads where possible, but if we move out into the terrain, we are actually doing a true terrain route analysis. In the demo, we also have two danger areas. We have a minefield and we have actually an enemy observer with a line of sight. So we can see that we need to actually take this into consideration. So if we move away the observer, we might actually come into a place where we can't even find a route because the observer now is able to see any path that we really could take here. But if we might find a way around this area that the observer finds, and the same goes for the minefield here. And we are actually using an amphibious vehicle, so we are allowed to pass into the water. So if I put the minefield so that it blocks our path at land, we can actually go around it over the lake, but it of course is going to take us a lot longer time. And finally, as a final step here, I'm going to visualize a terrain accessibility analysis. And this is a traditional driving time isochrones visualizations. We are analyzing from the starting point which areas are accessible within certain times. So the lighter areas indicate 5-10 minutes driving time up to 30 minutes driving time. So this is a quite easy way to see how long you can expect to travel, or how far you can expect to travel within certain times from your starting point. And depending on how much roads are available, the terrain and the elevation, etc., this is going to change when we change the starting position. And again, all of this is rendered server side. So the only thing we have on our client is the small line vector with a start and an endpoint. So there are, of course, many more built-in analysis functions that can be published as interactive services in Camenta Server Core. And of course, with the custom components that we looked at in the demo, Camenta Server support a lot of other analysis functions that you can implement yourself. So if you have custom algorithms, they could easily be transferred to a custom operator or a custom data set, for instance. And you can publish these as completely new analysis services other than what is available out of the box. So hopefully we have given you something to think about now, what can be accomplished with not too much work, neither on the client or on the server. So with that, we are almost at the end of this webinar, but before we end, I would like to go through the questions that you have sent in now. So Thomas, if you would help me out and read the questions for me.
Yes, sure. So let's take a look here. Okay, great. We have a couple of questions. Guys, remember that we have a Q&A button down below in the Zoom client if you want to send in your own question, or you can also use the chat if you prefer that. But yeah, okay, I'll start with the first one. Okay, so will the demos be available after the presentation?
Yes, absolutely. So I have a download link that I would be happy to share with you. Let me just show you my contact info again here. So please send me an email if you would like this download link with the information. Of course, feel free to contact me if you have other things you want to ask about as well.
Okay, great. Okay, so here we have one about operating systems here. So is it only possible to run Camenta Server Core on Linux?
No, Camenta Server Core, it can be run on both Windows and Linux and cloud platforms, for instance, Azure and Amazon. So as long as there is a Docker engine running, you can run your Docker containers from one of the Camenta Server Core images.
Yes, yes. Okay, let's see here. We have another one here. Okay, so this is about the custom components here. Okay, so are the custom objects included in Camenta Server Core and Camenta Server Core SDK?
So the custom components are handled as an extension to the Camenta Server Core SDK. So I think the easiest, if you are interested in trying this out or would like to discuss the how to get access to this, I suggest that you either contact your Camenta sales rep or you can contact me and we will help you getting started with this.
Yes. Okay, nice. Okay, we have one last here. Okay, let's go on. So it's about the run command for the Camenta Server Docker images. It's kind of messy. Are there any alternatives for starting your containers and deploying multiple containers?
Yes, it's actually possible to start your Docker container from in several different ways. And if you're experienced with Docker, you probably know this. I tend to use the run command because I think it's a very easy and convenient way to start a single container especially for testing and development purposes. But I normally copy this into a PowerShell script so that I just run the script. But of course, if you are doing more advanced scenarios, if you have multiple containers, if you have services, if you deploy things, you are probably more looking at, for instance, compose files, Docker compose files, or if you're using orchestration frameworks such as Kubernetes, you're going to use the Kubernetes configuration files to define all your different services and containers. So the Docker run command is primarily, I think, for simple tests, for instance. There are in the Camenta Server Core SDK, there are some samples that describe how to use both the Docker run command and compose files that hopefully help you get started.
Right. Okay, so let's see here. Yeah, that seems about it. So that's all the questions we have gotten so far.
Okay, great. So as I said, if more questions should come up later, or if you just want to discuss possibilities of publishing analysis services or other topics, feel free to contact me or your sales rep, of course. So with that, I think we are at the end. I hope you have enjoyed today's webinar and that you found something that might be of use to you. Again, feel free to reach out to us. With that, I would like to say thank you and thanks for attending and goodbye.
Take care, everyone. Bye-bye.